We are starting a new topic, algebraic expressions. So, in this topic, we'll be covering these things. First, we'll talk about algebraic expressions in polynomials. Then, we'll understand how to classify polynomials based on the degree and the number of terms. Then, we'll perform operations on polynomials like we have done with number systems, including addition, subtraction, multiplication, and division. We'll see how to factorize polynomials, how to find their HCF, and then finally we'll try to understand what do we mean by the value of an expression and what do we mean by the zeros of a polynomial. Let us first understand the concept of a constant. So a constant is a number that doesn't change. Its value remains the same no matter what. Its value will remain the same. See, some examples of constants could be 4, 2 by 5, say 7.5, say minus 3.8 bar. So even minus 3.8 bar would be a constant. So if it is minus 3.8888 and so on, so this is nothing but minus 3.8 bar, and this is also a constant. So these numbers are fixed and they do not depend on any other value. Now we have what are known as variables. So unlike a constant, a variable is something, it is a symbol that can take different values. So for example, say we have P or Q, R, S and so on. So these are all variables because these can represent any number. Now let us understand a few properties of variables. So first is with respect to variables raised to powers. So if a variable is raised to a power and the power is not 0, then it is still a variable. For example, say P is that variable and we have raised it to the power of 3. So P is a variable and we are raising it to a non-zero power. So then P cube is also a variable. Similarly, say we have Q and we are raising it, say, to the power of 0.75. Now this is power is non-zero and it's a variable, so this will remain to be a variable. Similarly, say we have t to the power of 1.5. So a variable raised to a non-zero power will always be a variable. This is the first property. Second property is product of a constant and a variable. So when a constant is multiplied by a variable, it remains a variable. For example, if we have 4p squared, so p squared is a variable, and if you are multiplying it with a constant, so this product will remain to be a variable. So minus 6q would be a variable because I'm just multiplying it with a constant. And similarly 7, say r to the power of 4, so this is a variable multiplied by a constant, so overall it will be a variable. Next property is with respect to combination of variables using addition or subtraction. If multiple variables are added or subtracted, the result would still be a variable. For example, if we have p squared plus q plus r cube, now each one of them individually is a variable and I'm applying addition as the operation, so this is also a variable. Similarly, say I have t cube minus q to the power of 4, minus r squared. So this is also a variable. Because individually each of them is a variable, and I'm combining these variables using subtraction. So this will still remain to be a variable.